man. I'm gonna need you to go on YouTube, go on the stream and see if you can hear my voice and if it's too loud and stuff like that. I did, but I didn't know it was this popular. I didn't really pay attention to it. It has been a long time since I actually went back to it. I don't know. I mean, I used to watch the videos like I mean, listen. I'm not gonna lie. I don't even remember why I watched. I didn't know it was this popular. I didn't really pay attention to it. It has been a long time since I actually went back to it. Alright, listen. Go to the video and tell me what's the audio like. Sorry, man. Oh yeah, Junaid's on. Alright, calm, calm. Alright, let's do some maths then. Oh yeah, Zain. What do you wanna do then? Go through integration. Hey, what the hell? What next man are joining? I love it. Yeah, go on. I know. Go through integration. Like what the entire chapter. Yep. Yeah, yeah, I see what you're saying. Basically, no. So the way it works is this. Look, let's say this is a function f of x. Yeah, and it has a root here at 1. Actually, let's simplify things. Let's just use a plain old hyperbolic parabola. This has a root of 3, for example. Yeah, this is f of x. Yeah, Zain. So if I did something like f of x plus 2, you know the new root is going to be this shifted to the left by 2. So it's going to be x equals 1. Yeah. So f of x, f of f of 3 equals 0. So yeah, f of x plus 2, f of 1 in here will equal 0. So x equals 1 is the solution. But if I have something like f of 3x plus 5, now you don't do the scale factor first. You do the translation first because it's to the x, and you do opposite BIDMAS. Uh, my camera on. Yeah, but doesn't it go along with the video? Oh yeah, you can just close the live stream then. You can close the live stream. What the hell? There's 6 viewers. You man, listen. I'll come to answer your questions in a bit. You get me? Anyways, um, yeah, f of 3x plus 5. So now you look at the translation first. So f of 3x plus 5 here. Oh my bad. So f of 3x plus 5 first is going to take it to minus 2. Yeah, minus 2 is here. And then parallel to the x-axis is going to be squished by scale factor of 3. So that will go from minus 2 to minus 2 over 3. Oh, I just clocked something. Oh, I just clocked such an easy way to do it. Bro, listen. If you see a transformation like 3x plus 5, all you have to do, and you know f of 3 equals to 0, you can just say 3x plus 5 is equal to 3 and rearrange for x. Yeah, sorry. What I'm saying is, if you know f of x equals 3 is a solution, and you want to know where the solution is for f of 3x plus 5, just make this inside bracket equal to this previous solution. This one. So 3x plus 5 equals to 3. If you rearrange that, you get minus 2 over 5. Minus 2 over 3, which is what you want. Because why am I equating it to 3? Because I know f of 3 in this bracket, f of 3 will give me 0. And what I'm looking for is f of 0. Is looking for 0, a solution. So if I just say 3x plus 5 is equal to 3, I can rearrange for x, and that'll tell me that the new root for this transformed graph is going to be at minus 2 over 3. Calm. Yeah, for f of 3x plus 5. And you can check, if you sub that in to f of 3x plus 5, you get 3 times minus 2 over 3, minus 2, plus 5, which is 3, which is what you want. Would it change for minimum and maximum, that method? What the method of equating the inside of the function? I'm not sure. Let's see. So, okay, what should I need to do this both at once or something? How should I do this? You know what? Oh, flip's sake. Man. I can't, I'm gonna have to just switch between, I guess. Funny. Um, okay, so let's try this for looking at minimum and maximum. If you have the function f of x is equal to x minus 1 squared plus 3, we know that maximum of that is going to be at, well, the minimum in this case, 1, 3. Um, just to stick to Fortnite, allow it, man. um, okay, so we know f of x, uh, for example, like f of x plus 1 will mean that the maximum goes to 0, 3, because it doesn't affect the y. But let's see if it changes if you do f of 2x. f of 2x plus 1. We know that the maximum occurs at x equals 1. So I want to know where the new value of x equals 1 is. So I'm going to say 2x plus 1 is equal to 1. So that's x equals to 0. So that means that my new x value, x coordinate for, what do we call it, for the maximum, for the minimum is still x equals 0, and the translation doesn't affect it. This is kind of a bad example. I should do, let's say, something like 2x plus 4. I can say 2x plus 4 is equal to 1, and then that gives me x is equal to minus 3 over 2. So that's going to be my new x coordinate for the minimum. So I think it does work. It generally does work. Um, cool. Oh, I should link this. I should probably link this when I in the group chat. Um, it's already linked. Bro, that's just one part of it. Yo, Bean, cool, listen, you asked what, to go through integration. What integration do you want to go through? If you're even here, that is. um, I've got some integration questions. I'll just what do you call it? Work with, and you can see how it goes. Yeah. Okay, so this is the question. Given that k is an element of positive integers, A show that um that's part one. Part A. Okay, so part A. Mm, go through by parts and substitution. Okay, sure. Okay, this has a bit of substitution in it, and then by parts I'll look at later. So part A, 3x minus k dx. So you can do this two ways. You can either do this by substitution, or you can just do it by reverse chain rule. So um, for the sake of going through substitution, we'll actually do substitution. So we can say let u is equal to, okay, a good tip for substitution is always let it be the denominator. You'd rather have something messy as a numerator than have it messy in the denominator. So you can say for now, let u equals to 3x minus k. Um, and if you're thinking that, oh yeah, the integral of this is going to be ln, yeah, you could have done that through reverse chain rule, but I'm just going to go through substitution for the sake of showing it. So du by dx will be equal to 3. So that gives you du is equal to 3 dx. Or other way around, you could say that du over 3 is equal to dx. So you can either get it in terms of dx, so you can make the substitution of du over 3, or you can write it as du is equal to 3 dx. So let's say you have a 3 here multiplying dx, you can just take both of them out. It's more straightforward to get it in terms of dx, so the substitution you can cancel out if there is any um, cancellation to be done. Okay, now here because this is a definite integral, the limits are defined. You're going to have to make sure that you change your limits as well. So here the limits x equals to 3k, so u will be equal to 3x minus k. So 3k minus k, that's going to be equal to 8k. So that's 8k, and then 3 times k minus k is 2k. 1 over u du. Yep. Um, okay. So that gives you 2 ln of u with the limits 8k and 2k, which will give you 2 ln of 8k minus ln of 2k. And then you can use your laws of logs to just do ln 8k divided by 2k. The k's cancel. This simplifies, and then you get something. I think I made a mistake somewhere. Ah, yeah, I didn't divide by 3. du over 3, this should be a third when I substitute my du in. So this should be 2/3, this should be 2/3. And yeah, that's part A. Yeah, part B doesn't have by parts, so I'm just gonna um, do something else. Do you have a question on you, Hasib? Mm, trying to find a integration by parts type of question. Nope. Wait, is integration by parts even in C2? Oh, I don't even know. Is it? Oh, no, not this. There we go. Oof, there's a lot there. Okay, let's see. I'm gonna do this one. How do I trim it? Um. Oh, there you go. Oh crap. Ah man. Oh, okay, that works. That's fine. Okay, so with integration by parts, you this entire idea of okay, I'm just gonna show where it comes from on the side here. So if you have a function, let's say the uv as a function, if you differentiate that, you get by product rule. So that's the same as d by dx of u um v times d by dx of u plus u times dv by dx. Now, if you integrate both sides, what you get is that uv is equal to the integral of v du by dx plus u, the integral, the dv by dx. And if you make any one of these a subject, you can say that the integral of of v du by dx is equal to uv minus integral of u dv by dx. That's where this comes from. This product rule different integrated and rearranged. So we can see that if you let one of these functions be v, then you can differentiate that and you don't have to worry about integrating v. You only have to integrate dv by dx. So for example, when you have x times sine squared x, if you let v be x in the future, you only have to integrate the differential of x, which is 1. So it's always nice to let your uh, v, or the thing you differentiate, be the thing that's simplest. So in this case, x. So generally, you want it to be x squared, or something like ln x, ln of anything, in fact. You want to let that be the thing you want to differentiate. So here, you can say v equals to x, um, and du by dx is equal to sine squared. Um, I think this should be fine. Yeah. So we have dv by dx equals to 1. And then du has to be the integral of sine squared. Now, the integral of sine squared you get by converting this power into a n theta one. So you can say cos of 2 theta is 1 minus 2 sine squared x. So we have um, half cos 2 theta minus 1 sine squared x. This looks a bit messy, isn't it? Well, let me box this off. U is going to be the integral of half cos 2 theta minus 1. And then you do reverse chain rule. So to get to cos, you have to have sine, and because this is a positive cos, you have a positive sine. So I just hit integral sign should be there. You have half sine 2 theta minus theta, um, and this is your u. So writing this out fully, a quarter sine 2 theta minus half theta. This is a pretty messy u, to be honest. Do we have to use it? Yeah, we're gonna have to integrate with this again. But that should be fine. Why? Because when you multiply this by dv, you're just multiplying by 1. So when I reintegrate this, I'm just integrating another reverse chain rule, and this will just become, you know, 1 over 4 theta squared. So that's fine as well. Moving on. So we have this integral, pi x squared dx, is going to be equal to uv, which is um, this x times quarter sine 2 theta minus half theta minus the integral with the same limits. I haven't written the limits in, but I'm going to put the limits to this entire thing anyway. So um, minus the integral of u dv by dx. So u dv by dx is 1, and u is this integrated thing. So that's I'm going to take the quarter out. Sine 2 theta minus 2 theta. I've just factored out the quarter. D theta. Um, oh, I went to theta. I meant x, but you know, same thing. All this time, theta x. Okay. Let me check the chat. Well, right click and crop it. Yeah, I'm using a pen, so I can't right click the same way. I mean, that was a long time ago. Um, yeah, reverse chain rule there. So to get to sine, you need minus cos. You have minus a half cos 2 theta minus theta squared. And this has the limits of pi over 2, 0. I'm not going to actually sub it in. That's too long. I don't have a calculator on me. But you can imagine just typing this into your calculator, pi over 2 times this. Um, sine of 2 theta, that's sine of pi is 0. So this expression tends to 0. Half theta, so you get pi over 4 here. Cos of 2 theta, that's cos of pi is minus 1. This turns into positive half theta. So yeah, when you plug this in, you can imagine you're getting the pi squared from plus 4 and the 16 from factoring out probably from here. I don't know. Yeah, yeah, because you have 1 over 4 here times by 1 over 4 here from theta squared, so you get 16 from there, and the remaining things give you pi squared plus 4. Yeah, assalamu alaikum. Yeah, sure, 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 sure. Um, do you think I should I rub out the rest of it? Okay, sure, 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 sure. Yeah, cool. Yeah, and it was harder, isn't it? Yeah, cool. So I'll just talk through it on the live stream then. Um, cool. Um, so yeah, there's going to be a bit of a delay, but so basically the way the strategy in choosing what to let v equals, I think in a book it's actually u and you differentiate u, but what I'm trying to say is the thing you want to differentiate is a thing. So let's see. So there's two main ways to think about it. First main way is, will by differentiating it, will it become simpler? So, for example, differentiating x will give you 1. Differentiating x squared will give you 2x, but then you can differentiate that again and it will give you 2. So, that's the first strategy is, does it simplify to a constant, I guess. Does it simplify to a constant? And the second is, um, I mean, the second is not a strategy, but if you see ln x most like 9 out of 10 times, that's the thing you want to differentiate, because that straight away goes to 1 over x. And if you imagine something like, if you have x times ln of x, I'm writing in the top right by the way, if you have x times ln of x, ln of x, and you choose ln of x to be the thing you differentiate, that will give you 1 over x, and when you multiply that by x times 1 over x, this gives you 1. So that's very easy to integrate. Whereas x ln x is pretty hard. Um, if you tried to do my first strategy, which is, oh, it simplifies, yeah, yeah, let me choose x and differentiate that. Yeah, you get 1, but you're stuck with integrating ln x. That's the problem. So, okay, I guess that's another way to say it. Choose the thing that's hard to integrate. So, x sine squared, okay, that doesn't work here. Sine squared is not hard to integrate. I mean, harder to integrate, but still you didn't choose it. So I guess it varies. In this question, I chose x because it turned to 1, and I knew I could integrate sine squared. In x ln x, it's harder to integrate ln x, so I choose ln x. Yeah. Type in the chat if you have, or you can WhatsApp me if you have any more question about that. Cool. Uh, this is integration by parts and substitution. Yeah, that's it. Um, I should go to the book. That's a good idea. Pearson. Well, let's say, what's my password? Uh, A Barania one. Uh, they changed the passwords or something in it. What was it? Um, VHS maths maybe. Wait. Oh, oh, shit. Crap. Um, let's ask. Yeah. a bit deep. Can I go over series? Yeah, sure. Um, do you have like a series question or like a type of series? So then, um, yeah. Uh, series. Damn it, man. What the hell? Madass probably has something on series. Oh, do you mean series expansion? Oh, okay, okay, sure, 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 sure. Um, cool. Oh, that's nice. I can. Okay, so it's a slight pause. I want to check if you can't see the screen, and then I'll resume it shortly. Okay, nice. It did freeze the screen. Okay. Rotate. Can't rotate. Come on. Uh, flip's sake. There you go. Yeah. Okay. Um. Uh. Okay. Cool. Oh, where's the rest of my paper? Flip. Flipping have to outsmart the system to get this, man. Alright, calm. Okay. I hope this is the type of series you wanted. I don't even know if you're listening, but you can rewind the stream if you want. Um. Okay, so use the binomial expansions. Use binomial expansions. Okay, so I'm probably gonna have to expand both of these things. Is what I'm thinking. Um, this is square root. I can express it as 1 plus 4x to the half. Yeah. Student substitutes x equals half, both sides of the approximation shown in part A. Oh, okay, part A, 6 marks here. First, gotta do this and then read this, but I'm just gonna have a read. To find an approximation to root 6. Give a reason why the student should not use x equals half. So whenever, okay, so typically in series expansion questions, whenever they ask you to say, whenever they ask you, oh, should you use this x value, or should you not use this x value, the main thing it always talks about is the the limit. Like I don't know the specific wording for this, but is your x too large so that your expansion diverges? The key thing is when something diverges, it gets bigger, 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 and you can't really find the finite like the infinite value of it. But when something converges, then it will look something like this, I guess. So each term gets smaller and smaller. When you add everything up, you know at infinity you will have a specific point. So what I'm trying to say here is x squared, x cubed. These things are going to get bigger and bigger for x equals half. And you might say, oh yeah, obviously the power is increasing. If something is I don't know, greater than one, it should get bigger. But it's very specific to the expansion itself. So for example, when you have 1 plus 4x, um, you don't want this term to be bigger than 1. So you say mod of 4x has to be less than 1. This is not even the part A, but I'm just going to briefly talk about this. And a mod of 4 is 4. So 4 mod of x has to be less than 1. Therefore, mod of x has to be less than a quarter. In general, whenever you have something of the form a plus bx to some power n, you factor out the a first. A to the n, 1 plus b over a x to the n. This is a very general thing, so it's important to, I guess, have a look, I guess. I don't know. Then we want this term to be less than 1. So mod of b over ax has to be less than 1. Therefore, mod of x has to be less than a over b. It is a very general thing. You don't have to remember it, but you just have to keep in mind that you want to have it in the form of 1 plus, kx, something like that. Okay, cool. So I'm going to begin part A here. Leave that on the side for a bit. Um, yeah. Now this is in the denominator, so I'm just going to bring this up top. It's a times 1 minus x to the minus half. Um, okay, now key thing to know, one thing to know is that the highest power is x squared. So that means for each of these brackets, I don't have to go up to x cubed. Now, you might ask yourself, do I have to go up to x squared for each of these brackets? Like, if I have 1x and x squared, do I have to have this x squared term? You might think maybe not, because there's a 1 plus x here, there's a 1 plus, not necessarily 1 plus x, but you work out something with an x term, and then the x here and then the x here combined to give you an x squared. You're right, it will. But this x squared will also multiply by this 1 to give you an x squared coefficient. And the x squared from here can multiply with this one to give you an x squared coefficient. So there's not just one thing to consider. You have to consider all the ways to get the coefficient of that power of x. Um, so yeah, so basically what I'm trying to say is it's 6 marks, you have to do 6 marks worth of work. TLDR. Okay, so because it's in the form 1 plus nx, you can 1 plus this x to the power of n, you just apply the formula. So 1 plus n half x, which is 4x in this case, plus n minus 1 over 2 factorial. Now people can write 2 factorial like this, but I like seeing everything in a line. So I'm gonna write 2 factorial as this. It's the same thing. Valentine's 1, 2, 3. Safe, bro. Oh crap! That was typo. Capital V. Ah, alhamdulillah. Um, probably a 2. I'll just keep this here on the side if we need it. Okay. Okay, but this is still for the first expansion, by the way. So this is all for the first expansion. 1 plus nx plus n minus 1 over 2 factorial x squared. 4x squared. Now the squared applies to both the 4 and the x. Keep that in mind. Okay. This now times, I'm just going to expand this straight away because it's very simple. It looks pretty simple. So 1 plus n, which is minus a half, x, which is minus x, plus minus half, minus 3 over 2, 1 over, divided by 2 factorial is the same as multiply by half, x squared, so minus x squared. It's a pretty long line, but this all follows. This is like crash course in series, I guess. This is a very typical series question, so if you understand this, understand the working out for this, we'll use 3 viewers, I think. But yeah, if you understand this, then you should be able to approach most of the series questions at least. Uh, Now the rest of here is just arithmetic. You can do all of this in your calculator. It does it very quickly, but I don't have a calculator on me right now. Um, 1 plus 2x plus, now you have 2, 2, 2, so that's 2 cubed on the denominator, and this is 2 squared squared, so you have 2 to the 4 here, basically, what I'm saying. So 2 cubed in the denominator, 2 to the 4 in the numerator, you just get 2. This minus carries over, so this should be um, a minus, and then you have x squared, minus 2x squared. So 1 plus 2x minus 2x squared. Pretty nice. Multiplied by, minus minus cancel out, so 1 plus half x. Now you have two minuses, and then this minus squared, so this will be a plus. You know, okay, well, that's the next question. Um, yeah, you have two minuses and this two minuses, so four minuses all cancel out. You have two cubed in the denominator, but you don't have a 2 in the x squared, so I can't do the same trick. You just have 3 over 8 here, plus 3 over 8 x squared, um, and these two things multiply now. So first get your coefficient, the constant 1. Now, ways to get x. 1 times half x plus 2x times 1. So these are the two ways to get a coefficient of x. You keep this in mind. You can't have x squared times 1 over x. There's no 1 over x. So these are the only two things I consider. So now I can write plus x lots of a half plus 2. Now x squared. Okay, x squared I can get from this 2 multiplied by 1. So x squared. I can get 2 multiplied by 1. I can get um, this 2x multiplied by this half x. So that's just plus 1, because 2 times a half is 1. I can also get this one multiplied by this 3 over 8x squared plus, my mistake, this is minus 2. This is a minus 2. This should be a minus 2. Let's see. Working out, it has to be neater, man. Minus 2 plus 1 plus 3 over 8. Yeah, there you go. X squared. And this will give you exactly that. 1 plus 5 over 2 x minus 5 over 8x squared. Um, oh, and you have to keep in mind, once you start, so this is true, that the initial expression is equal to that, but the initial expression is not equal to this, it is approximately equal. So you start doing your approximately equal signs here. Miss May likes to be quite, I don't know, pedantic about this, because mathematically it's not accurate to write equals. You have to be approximately equal. So anyways, you should get full marks either way, I think. At least maybe 5 marks, but it's worth the extra effort. Um, okay, I want to stretch this out. Okay. Give a reason why the student should not use x equals half. Okay, so I went over this. This is basically part B. This is the reasoning that we don't want this 4x to be the minus one minus x is fine. This is saying that mod of x here, so mod of minus x has to be less than 1, and mod of minus x is the same as mod of x. So x equals half satisfies the bottom, the denominator, or the bottom series expansion. But for the top one, 1 plus 4x, if x is greater than a quarter, it won't satisfy it. It has to be less than 1. 4x has to be less than 1, so x has to be less than a quarter. A half is greater than a quarter, so um, my reasoning would be at least that the series expansion diverges, and the approximation is not accurate. For It's just not accurate. Yeah. Okay. Um. Okay. Now the last part. Now they all, most of the time, it's not straight, it's not direct. This approximation root 6 you don't get straight away. You have to manipulate your surds to be able to get root 6. Sometimes what they do is the person will try to get the approximation of root 6 directly. Maybe, I don't know, substituting a value of x such that 1 plus 4x over 1 minus x is equal to 6. But the problem with that would be something like this. In fact, if you use x equals half, you do get 6. 1 plus 4 times a half, that's 1 plus 2, that's 3. Over 1 minus half, that's 3 over a half, that's 6. So that does give you root 6. So that might make you think, oh, he should use the approximation. He should use x equals half to get this approximation, but you shouldn't. You have to find some other way to get root 6. Now, they're nice, and they've given you the substitution. I've seen some examples where they tell you, oh, okay, clearly you can't use this value. Find a substitution to use to be able to get an approximation for root 6. and those are I think are slightly harder and give more marks. Am I even talking to anyone? Before I carry on talking. Yeah. If it's even like one person, oh, 6 people. Okay, that's fine. Um, do do one is negative to attribution. What the hell? Do one is negative. Okay, yeah, yeah. That's basically I said that. Um, here. So the negative one, the minus x when it's mod of minus x, you just say that's the same as mod of x. So mod of minus x, mod of minus x has to be less than one. Mod of x has to be less than one. Same thing. Um, this might look slightly messy, but everything's in line. Uh, a trapezium. Okay, I'm gonna finish this question off, and I'll do the trapezium rule afterwards. Okay, cool. So they said x equals 1 over 11 to get an approximation of root 6. I'm not going to actually substitute anything, so I'm going to finish this pretty quickly, but this is the process. So this is part C. 1 plus 4 over 11 over 1 minus 1 over 11. That's basically what you're substituting in. That gives you 15 over 11. That's 1 plus, that's, just adding fractions. 1 minus 6, so that's 10 over 11. Now, two fractions on top of each other, there's, people have their own ways to do that, but that's basically 15 over 10. And again, keep in mind we want to get root 6 out of this. So first, you can simplify this. You can say this is the same as 3 over 2. Now this is pretty promising because we know an approximation to root 3 over 2, we want root 6. Now, we can multiply this by a constant to get root 6. That's the thing you have to spot. I don't know how, there's a way to do this otherwise, but just I guess figure out. So 6, you, to get 6 out of 3 over 2, you have to multiply by 4. But because it's in a root, you're multiplying this by 16, and that's the key thing. So what I'm saying essentially is 16 root 3 over 2 is root 6 exactly. So if you use the approximation x equals 1 over 11 and substitute that into your series expansion from part A, 1 plus 5 over 2x minus 5 over 8x squared, you will get root 3 over 2, not root 6. So once you get root 3 over 2, just multiply that value by 16, and that will be your approximate root 6 to as a fraction in simplest form. Yeah. Okay, cool. Mm, yeah, I'm pretty sure you can rewind and stuff like that, so I'm not going to save this or linger on. I'm just going to go straight to trapezium for my brother, Bejan. Is he still there? Yeah, quick time, quick time. Okay, trapezium rule. What's the trapezium rule again? Um, okay, cool. So, do you have a trapezium rule question, bro? Oh wait, but Ishak sent a question as well. How do you know the arrangement? Okay, yeah, okay. So this is a message for everyone. Um, okay. So whenever you are given shapes, in like vector planes, in vectors or planes, always, um, okay, how should I say this? Always label the vertices clockwise or anti-clockwise. Most of the time it doesn't, like, they don't hint to you which one should be where, and you might think, oh yeah, but they give you values for the coordinates, so surely you can figure it out. Yeah, you can figure it out, but it doesn't really matter. It would look weird. Like, you might think that obviously 6 is bigger than 2, but you've drawn 6 to be smaller than 2. It doesn't affect the maths. Your maths is fine. Your entire point of drawing diagrams is not to solve maths, but to give you an insight into the question. So um, yeah. So, for example, the mock we done, the last question with proving it was a trapezium, A, B, C, D. What you can't do, sorry, man. Bro, I've saved you as Daniel Haircut since year 12. I haven't changed it since then. But yeah, this is your trapezium. This is fine. A, B, C, D. Perfectly fine. This is completely wrong. You can't do A, B, C, D. This is a big no-no. Why is it a no-no? Because the reasoning is because most questions assume you're going to. I mean, not assume. It's like a known thing that you should label it clockwise or anti-clockwise. Um, So in the trapezium question, they gave you AB and they gave you CD or DC, and they told you that it wasn't parallel. Oh, no, they gave you AD and BC, sorry, and they showed it was like 0 and this was 2, and it was like 5. This was 7. No, this was 5 and this was 7. Um, yeah, but the point is, and it was 3D, so there was something here as well. But the point is that these two are non-parallel vectors. So you know that the trapezium would have its parallel sides up on AB and DC. Now, is AB longer than DC or is DC longer than AB? Doesn't matter. The thing you have to identify is that these two are parallel. Um, so yeah, I hope that answers your question, Ishak. I didn't even send it. Crap. When we given shapes and vectors or planes, always label the vertices clockwise or anti-clockwise. Uh, Print screen. Does that work? Chase. He's gonna look at the rest of the gibberish and think, what the hell's going on? Come. Um, who had a question? Oh, Bejan, Bejan. So my bad. Sorry. You even there? Yeah. Oh, Ishak. Oh, you're on live stream. Nice. um. Okay. Trapezium rule. Have you sent one? Have you sent one on the group chat yet, Bejan? What am I meant to? What question am I meant to answer? Um. I'm looking for a question, by the way. So. Or I can just mad as mass. Or I can just. Oh man, sorry. I have resources. I should use them. Um, Algebraic methods. No. Function in graphs. No. Is it year one? Yeah, it's year one, isn't it? Yeah, it's year one. Man, if I was co-hosting the stream, it would be nice. I had someone to talk to, but flipping, damn it. Um, Umi, Umi, दूसरे room में जा सकते हो? Uh, Crap. Is it not in year one? The whole trapezium, bro. I swear down it was. Uh, it was a method. It was like a. This is year two. Um. Yeah, I can't find it, bro. Integrate. Oh, there we go. It's there. Sorry. Found it. Oof. Wait, what? Okay. 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 Let's find a question. Um. I don't want to do too much work. Let's just do this. Um. Use it to remove all the values. Okay, I'm gonna do this one. This one. Oh crap. Okay, so um, I don't know if you want me to go through how to answer the question or the concept of Trapezium rule. Simple question: would we always be told to do iterative, or what do we need to know? Most of the time, they'll tell you to do one or the other. So um, but in general, I think it's got to do when you have like a polynomial, like I don't know, x squared, x cubed, something simple that you can rearrange pretty simply and get one of the x's to be the subject, preferably the largest x. Like if you have x cubed, x squared, x and a constant, you rearrange to make x the fourth to the subject and then fourth root, for example, and you can do the normal iteration on that. But when you have like a more complex function with a lot more curves and stuff like that, that's normally when you do Newton's-Raphson. But all the questions I've seen, they specifically said using Newton's-Raphson, find x4. So yeah. Okay, trapezium rule is basically when you have functions that are hard to integrate, or functions that you can't integrate or you don't want to integrate or whatever, you can use this idea of trapeziums to approximate the area. It's the equivalent of when we were in GCSE, when you had the grids, um, and what you used to say is that when it crossed the square, you can count that as half a square and add up all the half squares, and then you work out the total number of squares, and that's the area. But you're not being that specific; you're just approximating to little slits. In this case, we have a slit at x equals to 0, 0 0.5, 1, 1.5, and 2. So, no problem. Okay, uh, my question is, do you want from the mock? Oh, okay, okay, cool. Run this question then. Do you have a online document of the mock, online version of the mock? Uh, do I have online version of the mock? Maybe somewhere. Um, yeah, let me somewhere here. Hmm. Where the flip is it? Nope, can't find it. Is it? No, that's further. Okay, cool. Ayo, if you have a photo, send it over, please. I'll do it from there. Pretty. It'll be easier to do from there. How much of a delay is there between the stream and me? Ayo, if you have a photo, send it over, please. I'll do it from there. Pretty. It'll be easier to do from there. How much of a
Sorry,
delay
Ahmad.
is there between the
My
stream
voice is annoying.
and me? Uh, until then, I might just go through the hardest thing of yet too. What time is it? Okay, 12. Okay, almost 12. Um, let's see. Hardest question from Madas Maths probably be better than this rubbish. Um, Maths, no, Maths A level practice. Ooh, 2019 spec. Synoptic. Sure, sure. Okay. Oh, what the flip. Okay. Oh shit. Uh, E. Okay. E's there. H. K. Okay. What's this? Oh, this question. Okay, cool. Wait. Oh, crap, I didn't copy it. Oh, is this even helpful? I don't know if it's a waste of everyone. These are the ones for okay, cool, cool. I'll do the this one first, and I'll do the second one. Brush. Okay, show that uh the sum of ln of p to the n is k ln of p. Okay, cool. So my tip would be when you have like weird series, okay, non-typical series. Of arithmetic series, you can do the sum of, and you have the formula for and whatnot, etc. It's fine. But this is a weird series. It's the sum of a weird function. It's a different function. So my tip would be whenever you have something weird, do the first couple steps or the first couple ends and just write it out and try to see if you see a pattern. And maybe you can see a function or property of the function you can use to solve this problem. So just try some ends. So first of all, I'm just going to write this out. ln of p to the n is equal to k ln of p. That's what I want to show. So let's try ln of n equals 1. That's ln of p plus ln of p to the 2. This is p, like this is, it's not ln of p to the power of n. This is p to the power of n. And it's specified that. So plus ln of p cubed, etc. Now, this isn't a geometric series because, as I said, this is ln of p plus ln of p squared, not all of ln p squared. If it was, that would have been a completely different question. You'd have to do a geometric series. Interesting, uh, interesting opportunity. But for now, this is not geometric. So what can we do to work with this? Well, the only the only like I don't know, next step or the next thinking you could think is that with logs or ln's powers, you can power down. So you have ln p plus 2 ln p plus 3 ln p up to 11 ln p. ln p. So now you can say all these ln p's are a common factor. So ln p 1 plus 2 plus 3. Aha! This is what we want. This is, lovely. It's the sum of the natural numbers from 1 to 11. And the formula for that is, well, there's two. It's the first term plus the last term divided by the number of terms. I think. Um, no, first term plus the last term times the number of, um, what the hell? What's the formula? A plus L in all circumstances. So, for example, ln of p cubed, this you can power down. ln of p cubed you cannot power down because this is not a power of p. This is a power of this entire number. But yeah, apart from that, you can power down, and you can prove this result. I wouldn't be surprised if they ask you to prove this result. Generally, by like generally saying that show that ln of p cubed is 3 ln of p, and the way you do that is by saying um, you start defining numbers. So p to, like, for example, p to a, p to the a, um uh let's see, one sec, p to the a. So you can write log of one sec, what was it, um uh, You have to define it. Okay, okay, yeah, you can say y is equal to ln of p. Ln of p. So then we have e to the y is equal to p. Now what you can say is start saying consider p cubed. P cubed is e to the sorry is e to the y cubed, which is also e to the 3y. And that's the key thing. E to the 3y is the same as e to the y cubed. And this similarity is the reason why you can power down ln of p cubed is the same as ln of 3 ln of p. Um, so that's saying e to the 3 times e to the y is equal to p cubed. And if you ln both sides, you have 3 ln of p is equal to ln of p cubed. Crap, this is actually a proper proof. I didn't even clock. This is a proper proof. Instead of 3, you can say a e to the a, ln of e to the a is a. So that proves your result. Okay, anyways, hope that answers your question. Uh, Rubbing eyes, I'm not nightmare. Okay, what's the formula again, man? I forgot. So I know it's one is half n plus one. That's one. Mm, I think first term plus the last term half n. Yeah, yeah, yeah. Okay, cool. Okay, now someone asked me the question of how do you know to use n or n minus one or something like that. So the way I like to think of it is always use small numbers. So if for example, if I have 5 chairs, one, one, okay, five square, 4 squares, 1, 2, 3, 4. The number of squares is going to be 4 minus 0, not 4 minus 1. So if I have squares from 1 to 4 in that range, the number of squares is equal to 4 minus the number previous 1, 0. And I can confirm that quite easily. So now if I'm going from 1 to 11 now, the number of numbers I have is 11. Um, that's obvious for 1 to 11, but for example, if you start at 5 to 11, sometimes it's hard to check. In this case, you have 11 minus 4 terms, 11 minus 4 terms, which is 6 terms. You can count on your fingers 5, 6, 7, 8, 9, 10, 11, but generally this is how I do it. So okay, cool. So this gives you first plus the last term, so 12 divide. Okay, so ln of p 12 over 2 times the number of terms 11. So that's 6 times 11, which is 66. 66 ln p. Took quite some time to do the first question, but that's just because I'm trying to explain everything. Uh, uh, okay, that's fine. 66 ln p. Okay, show that 8p to the n is 33 ln of 2p squared, and it's only 2 marks, so it shouldn't be too much work. How much was the first question? That was 2 marks as well. So there was only 2 things you have to do. One was power down, and second an arithmetic sum. Here, okay, the sum of ln of 8p to the n is this is the claim that it's equal to this 2p squared. So what do I have to do? First of all, use the properties of this sum. I'm not going to rewrite all the first couple terms out because I know that this question revolves around using properties of logs. So property of log here is ln of 8 times p of n. Um, so there's 2 ways. You have the first term plus the last term divided by 2 times by the number of terms. That's one way. And the second way is doing half n plus 1. So the number of terms is 11. 11 times 12 divided by 2. Why is it 12? Because 11 plus 1 is 12, and divide by 2, that's just the formula. Do you know, you do need to know how to derive the formula, so while we're here, I'll just show you. So 1 plus 2 plus 3, etc., up to plus n, the sum of that, let's say, is equal to s. Now, Gauss, when he was 10 years old, he's the one that discovered this when he was 10, so pretty crazy. So you can also write 10 as the same thing but opposite, n plus n minus 1 up to plus 1. And when you do sum these two things up, this entire thing, you get 2s is equal to n plus 1 plus n minus 1 plus 2, that's n plus 1, plus all these terms, plus n plus 1. So for every term you had, for every each of these n terms, you have now n plus 1. So that's the same as, you can factor n plus 1 out now, n plus 1, n times. And this is equal to 2 times the sum. So therefore the sum is equal to half n, n plus 1. This is probably like a 3 or 4 mark proof. So keep this in mind. Uh, back to this. So now you can say that this is a sum of ln of 8 plus the sum of ln of p to the n. That's good. This is from the first part, so I already know how this works. N equals 1 to 11. Now n equals 1 to 11. Now ln of a is a constant. There is no n in this entire summation. So when you keep on going from n equals 1 to 11, when you say, for example, n equals 2, you're adding ln of 8. When you say n equals 4, you're adding ln 8. So what you're doing, in fact, is you're adding 8 ln of 8 11 times. 11 times ln of 8. Plus here we have 66 ln p from part p uh, from part 1, ln of p. Now I have to combine these. I have to show that this is equal to that. So um, So first thing I see is a 33. So what does that tell me? That tells me that I probably might want to, and this is a p squared, so I'm just going to factor out 2 and power it on top. So that's 33 ln p squared. Yeah. Um. Oh, wait, is this 11? Yeah, that is 11. Um. Yeah. Okay, now 11. This is 33. This is 11. So this is 3 times greater than that. I want to somehow get this to be the same as that. I mean, it would make sense because what I'm trying to get is this number. I'm trying to squish into this inside here to get this 2p squared. Now 8 is not what I'm trying to squish. I'm trying to get 2 in there. So I'm going to write ln of 2, and to get 8 to 2, as in 8 is 2 cubed. So I've multiplied the outside by 3. 33 ln 2 plus 33 ln p squared. Now the 33's are common, factor that out. ln 2 plus ln p squared. Now using your laws of logs, that's just same as 2p squared, as required. That's done. Part B. Part C now is find the set of wait. Before I move on, yeah. Okay, cool. Yeah. Find a set of values of p for which this sum is less than 0, giving answer in set notation. Okay, first of all, I'm not even going to bother writing the sum down because I know that this is exactly that. And I can just use my previous result. It's going to be much easier to use my previous result than anything else. So I'm now have to show, find a set of values for which the ln of 2p squared is less than 0. 33, this you divide by 33. Now, okay, now you have to, well, you know when we divide or multiply by -1, the sign flips. Now the reason why the sign flips is when something, if you imagine something along a line and um, along the x-axis, for example, x equals 5 is bigger than x equals 3. But when I multiply by -1, 5 goes to -5 and 3 goes to -3. So -5 now straight away becomes smaller than -3. So that's why the inequality sign must flip. So that's the reasoning. But when we apply certain functions, you don't have to flip it. So if you multiply everything by 3, if something was smaller than something else, after being multiplied by 3, it will still be smaller than the other thing. So in essence, when you multiply or when you apply a function that's increasing, you don't have to flip the inequality. So why am I saying all this gibberish? Is because what I'm doing here is I'm going to exponentiate both these terms. I'm going to do e to the ln 2p squared and e to the 0. But because e to the x is an increasing function, anything that was bigger than something else previously will remain bigger than it after the function. For example, x equals 1 here was bigger than x equals -1. E to the x makes it go to e in this case, and 1 over e. But e is bigger than 1 over e, so the inequality is not affected. Okay, 2p squared now is greater than e to the 0, which is 1. Therefore, is this right? Yeah, that's right. Okay, p squared is less than a half, and now that is just a quadratic inequality. where you want to find this set notation for when it is less than a half. Um, and because it's p squared, it's just a normal inequality. Am I missing anything? Yeah, that's fine. So we're basically saying mod of p is less than root 2 over 2, or you can say that p is less than root 2 over 2 and bigger than minus root 2 over 2. I rationalized it, 1 over root 2 over 2. And that's your final answer. Cool. Sorry, yeah, you're right. Set notation, set notation. Set notation, is that the probability signs? No. So when I say P, I don't mean probability, I mean P as in this P. So set notation in this case is going to be, yeah, is going to be, one second, let me just get rid of this. Is going to be the set of all P root 2 over 2 greater than root 2 over 2. Wait, the set of all P, wait, chill. The set of all P such that P is less than root 2 over 2 and greater than minus root 2 over 2. Close bracket. This is set notation. This question just says P as notation. It's not necessarily probability. 'Okay, cool. If anyone has a topic or a question. 11% utilization. Um, you try. You just try your substitutions and see which one actually works out. So yeah, you and yourself. I get you. Most of the time, as in terms of my tips would be, to you let it be the denominator. So for example, if you have something like x squared over x cubed, okay, that's something you do substitution on. Let's say you have x over 2x squared plus 3x. Um, it's often better to let your u be the denominator. Wait, hang on a second. 2x plus 3. Is that fine? No, that's not good. Um, if you have a specific question, I'll let you know. But often, it's basically the denominator. Most of the time, actually not most of the time, but because you do further maths as well, you can get away without. We can get away with not doing substitution because mostly everything in A level maths at least is reverse chain rule, and substitution just helps you see that. So, for example, 2 over 2x plus 3, the integral of that. You could do the substitution. U is equal to 2x plus 3. You think you get du is equal to t 2 dx. This is dx. This is a 2, so this just becomes a du. So you have 1 over u du, and that's just ln u. But and u is equal to 2x plus 3. You can just spot that 2 is 2x plus 3 is differential. So because of that, you can just from the beginning say this, and it'll be valid. It should be valid at least, unless they say by substitution show the different integral of this is that. Yeah, that's it. If you have a question, send it, and I'll say, yeah. Okay. I have a question. I can I can test this myself. If I play something, can you hear it?
Do you know how much the
Okay.
price of milk?
Hello everyone and welcome back everyone. And
I can I can test this myself. If I play something, can you hear it?
Do you know how much the
Okay.
price of milk?
Oh, you can hear it.
hello everyone and welcome back everyone. And
I can test this myself. If I play something, can you hear it? Oh, they've given you the substitutions though. But how would you know? Well, okay. So for the first question, 5, you can see that x cubed minus 4 differentiates to 2x squared, which is what you have on the outside. So you can just consider, you can do this by considering the reverse chain rule. So consider x cubed minus 4 to the power of 3. That would differentiate to 3 times x cubed minus 4 to the power of 2 times the differential of the inside function, which is 2x squared. So it's a very direct reverse chain rule. In this one, it's specifically, but I'll do the full on substitution for the sake of substitution. If you want me to substitute, that is, I'm not sure if you want to see the substitution or just want to know how to do like how to find the substitution. If it's how to find the substitution, at least in A-level maths, most of the time they give it to you. Um, if they don't, then you want to make it so that the denominator becomes simple. Okay, another thing. Whenever you have something like 1 minus x squared, 1 plus x squared, square root of x squared plus 1, those more often than not, involve trig. And mostly, like, pretty much every time you'll have arc sine. Because 1 over square root of 1 minus x squared is the standard integral for arc sine. But the negative of this, so minus 1 over square root 1 minus x squared, is the integral for, is the standard integral for arc cos, which you almost never use because you can just factor that out. So minus arc sine of something is what you'd use more than arc cos. So that's one thing to, I guess, remember. Anyways, what was this question? Did I copy it? I did copy it. Too big. Back in action, doing some question instead of doing nothing. I'm tempted to play LC right now, man. uh, 2x squared x cubed minus 4 squared dx. So u is equal to x cubed minus 4 du by dx, or du is equal to 2x squared dx. I just multiplied by dx straight away. Now we have a 2x squared and dx there, so that's what we need. So that will just pop along to become a u, and x squared minus 4 is our substitution. So that gives us u squared du. Integrates to a third. This integrates to a third u cubed, which is equal to, I mean, this is limits 3 2. So you can't, not, okay, so this is limits 3 2. When you use the substitution, you either change the limits or go back to x world. This is a u world. This is a different world you live in now. So x equals 3, x equals 2, not to u. This is with respect to u. That's what it means to be with respect to. So that's the same as saying a third of x cubed minus 4 cubed. Yeah, that's right. Yeah, a third x, and then now you can say here 3 2. So let's try to do this quick time. A third. 9, 27, 23. 27 minus 23 cubed. Yeah. 8 minus 4, 4 cubed. Minus 4 cubed. Yeah, 23 cubed and 4 cubed. We're not really going to do, but you can find that. Okay, let me can I control the desktop audio? So, okay.
And especially congratulations to everyone who came to this video by clicking on the first.
Okay, I can mute it. Okay, I can mute it. Can I control the level?
This is now the Armageddon game between Magnus Carlsen and Ishwana
Okay,
Anand. They drew their classical game in the first round of the Altibox Norway Championship.
How loud does it sound?
And especially congratulations to everyone who came to this video by clicking on the first.
Okay, I can mute it. Okay, I can mute it. Can I control the level? Okay, that's nice. Okay, I can.
They drew their classical game in the first round of the Altibox Norway Championship.
How loud does it sound? Yeah. Sure, man. If you have one, I'll take it. Okay, that's nice. Yeah. Sure, man. If you have one, I'll take it.
If meat could help them cross treacherous waters, it can definitely help you power through work. Power through with 100%
Let that finish
lean
time.
beef. Jack Link's beef jerky.
Alright, cool. Where's the noise coming from? The hell? Oh, from here. Hmm. Oh, okay, yeah, yeah. You were asking about I think someone was asking about differentiation from first principles and what you have to know. So differentiation from first principles, you pretty much have to know for all polynomials at least. They won't ask you anything too complex, but for all polynomials and also I think actually I'm not sure if you have to know this, but also the proof for ln of x is equal to 1 over x. I'm not sure if you have to know that. I'll go through it if you want. If you if you want, I'll go through that. But I'll do this question at least. That's all. So it's just long. These questions are just long. Nothing. Once you get it, it's once you. Okay. So first thing, first mark you get for saying let f of x be equal to 2x cubed plus 5. You need this is a mark. So 1 mark. Uh, the fact that it passes through point P you don't use until the end. You just want to differentiate first. So you say f of x is defined as the limit as h tends to 0 for f of x plus h minus f of x over h. Now there's a couple different principles, different definitions, but I didn't even know there are different definitions. But the only definition we use is this one, and it's probably the simplest one to use. This is why it's probably why they teach it. Now f of x plus h is a substitution you make into the function. You don't just write f of x plus h. So next line, the limit. Okay, I asked Miss, do I have to write this every single time? She didn't give a very specific answer. I'm writing every time to be safe. Um, yeah. 2x plus h cubed plus 5 minus 2x cubed minus 5. 5's goal, the constant's goal. That's why constants differentiated are 0. But anyways, divided by h. Limit h tends to 0. 2x, I'm going to factor the 2 out. Now x plus h cubed minus x cubed. So you get from x plus h cubed expansion, x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed. This minus x cubed from this. X cubes cancel out. This is all over h. Now the remaining terms are all in terms of h, so what we can do is subtract a power from each of them. That gives us now the limit as h tends to 0 for 2 3x squared plus 3x h plus h squared. At this point, there's no fraction. It's just 3x squared and 3x h. You say as h tends to 0, 0, f tends to 6x squared. 3xh and h squared. 3xh plus h squared tends to 0. Therefore, f of x. Yeah, that's enough justification. Now for point P, x equals 1, not 7. F prime of 1 is equal to 6. They use differentiation from first principles to find the value of the gradient of the tangent. Not normal, so it's tangent. So that's it. That's it. That's the value of the gradient of the tangent. Oh, चलता है चलता है. No problem.
Alrighty, welcome back to Black Magic Forkery. Starting off with Predator type Stealth. What are you holding in here? What the? Okay, that's a squid, and that's a kid. Oh, so there's gonna be a comment be eaten, and I'm like, all of a sudden, I'm not fascinated by this, and I just feel badly seeing this one. Color changing hard. What does that mean? Color changing hard. That's a sentence. Oh, did you mean color changing arts? Perhaps. I'm Clippy, here to suggest an alternate title for you that fits a little bit better. It's one of the harder color changes out there. Some color changes, they're pretty easy. Rainbow easy by this dude. What is happening? Wait, what is the floor move? What the heck is going on right now? This cat has found nature's VR treadmill. Pretty soon, it looks like a handrail on a set of stairs, but it's actually used for a second. I was like, how is this cat doing it? Hard trick. Really? You can, no, yeah, okay. Ooh. You know, that's cool. I remember I won dedicate. I'm gonna prove them wrong. I'm gonna make it so you can. How did he freeze in the air? Wait, what do you mean?
I saw this on Instagram somewhere.
Okay.
I think he puts his foot on the bench.
Hold on,
the
there's
side,
gotta
but
have
it's just
been like a.
It's covered by his left leg.
On the bench.
Yeah.
Right. Okay, this for long walks on the bottom of the ocean to fetch water to bring back to feed my household or allow us to shower. The water that I'm walking through is a little bit too salty, but did you know you can get some really heavy fresh water? It kind of resides on the walking through.
Oh crap! That's not water, that's bubbles, and that's ice. Oh crap, that's really sick.
Allow us to shower. So you can get it up, let the salt. One square uncut sheet of paper. Is it really a square piece of paper? The heck? Report you make stuff absolutely breathtakingly complex origami dragon from one sheet of paper. As much stuff as there is on YouTube, I'm curious high-level art that's proprietary that no one would ever share this. I don't know, dude. Dancing, but how? Are we about to see some like, oh my god, my ankle hurts right now. Ow, god. How do you... It's impressive, but also just seems like a lot of pain. Are you wearing some kind of brace on your foot? That's the only way I can imagine this would happen. Oh my god, dude. It's just painful. They can't... God, dude.
Oh.
Dark. Because that is only. Sand brewed coffee. What is happening here? I don't understand. What? Is the sand hot? Is there so much friction from it being coarse and rough and getting everywhere that apparently it's able to brew coffee? If I just take a pot of water to the beach, put some coffee grinds in there and just run it along the sand, will I end up getting hot coffee from that? I don't understand what's happening here. In sieges, they used to heat sand and throw it over the walls at attackers. It would get under their clothes and armor and... Okay, stalker. The sand is hot, boils the coffee, the froth is poured off, repeats. Fresh coffee, the sand is... What the... Oh, an invisible force field. What the... Oh my god. Is this some kind of like volcano vent? So, is that off the edge? It's just wind, like an updraft against the side of the clip face. But thermal wind, okay.
Monday.com is a team management tool that changed my life. I can see where all of my projects are at a glance. My team knows what.
Except it's waves on a cliff. Oh yeah, it is. It took me a moment there. I was like, which direction is what and what's the perspective? Okay, this is just a roof that's sort of in the foreground. This is the cool. That's nifty though. The heck? I'm pretty sure we've seen something like this over on Shorty Car Mods. Man, you take Star up this. If a cat can fit its head through something, it can go through perfectly fine. Go through it. Just a theory, though. Oh god, is it going to be able to go through the entire thing? Is this cat actually an octopus? I'm pretty sure this is not I don't think that's supposed to happen. Meanwhile, the person with the camera is just like, I'll observe as this cat runs away. Bro, if the cat can fit through that, I'm sure it can also fit under a door.
Go.
Or it's just gonna be able to, like, go under the door. Like, thing. Terminator cat, okay? Touch my face, not this one. Oh, wait, is he backwards the whole time? Wait, what? How did he do it that quickly? How did he make that's what happened. It was ask in it's bad didn't want it see it's a better trick. Watch till the end. Wow, 15 gold awards here. This is gonna be gnarly. I remember having my signs falling off level though. Wait, what? Oh, freaking! It doesn't. Why? Just said you damn. All right, what is about to happen? Is that's backwards, right? It doesn't. I've never smoked a cigarette, so I don't. Wait.
The sleight of hand, man. What the hell?
What kind of sleight of hand keeps happening here, dude? Okay, hold. I want to. Does he just have the fastest fingers on the planet? And he can somehow like.
What the flip?
Wait. Hold on. Is it double? Is it
That's sick.
both? Maybe. A one-way TV that you can see through from the back. Oh god, no, really? It's like, oh, that's wild. I mean, I guess one-way glass that exists, right? Yeah. Stuff. Anyway, that's there. See you next time.
Oh, sorry, I didn't even read this, man. Could you go through the conditions for an increasing, decreasing function, min, maximum points, and inflection points? Yes, yes. Okay. Minimum, maximum points, and inflection points. Okay, cool. So, sorry, man, I didn't even read that. Yeah. Maybe you can message me on WhatsApp as well. I'll read it there. Okay, cool. So, nah, let's not make it too complicated. Yeah. It should be curvy like that. Okay, cool. So we have two stationary points. That's it. Those are the simplest ones to do because that's one. So this is f of x. These ones are the simplest ones, I think, because we've been doing them for a long time. Where we just say f of x is equal to 0. Now, obviously, we can't see f of x when we're working with the numbers, so we want to see is f of x the first, like, a solution we found a maximum or a minimum. Now, the understanding behind, I mean, when we were taught this, I don't think we were taught how to think about this, how to understand this. But this is how you should understand it. Oh crap, convex and concave. I don't know which one's which. I'll have to look that up. But basically, look, f of x is the tangent at any point. So with different color, with a different color, with yellow. Okay, that's a bad choice. Purple. These are the tangents. Now, the steeper it is, the more positive it is. As you go closer to a stationary point, your the value of your tangent changes sign. Yeah, much like how a function changes its y value from positive to negative when it crosses a root. So when f of x is at a root, it changes its sign. So here it's positive, positive, and then as it goes down, as it carries on going down, it's becoming negative. It's becoming negative. So it started off positive and it ended negative. So what's happening? The function, the gradient at this point is decreasing. Let's say this is alpha. Um, not alpha. Let's say this is the S1 for stationary one. So if I did the second derivative, which is saying how does my gradient change at this point? What's the rate of change of my gradient? And I sub in f of S1. If that is negative, so less than 0, if it's negative, then S1 is a maximum. And the entire argument applies in reverse. So here the gradient is negative and it becomes 0 here, and it becomes positive. So the rate of change of my gradient is positive. So if I get f prime prime of S2 is greater than 0, then S2 is a local minimum. A point of inflection. A point of inflection is a point where the gradient, well, it's like, okay, you can see how the gradient here changes quite quickly from being very positive to being quite negative. But there's this little region where the gradient seems to stay constant, and that's the idea. It's when the rate of change here, when the rate of change of your gradient is equal to 0. So what I'm doing then is saying f of f dash 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 x is equal to 0, and finding x. So this is going to be my point of inflection. Let's call that I, or xi. You know, in xi. And that's the condition. A point of inflection is the rate of change of the derivative is the rate of change of the gradient is 0, but that does not mean that the gradient is 0. It's not necessary. This is a inflection point where the gradient is 0 and the rate of change of the gradient, and that's a cubic functions have this property where the point of inflection is also when the gradient is equal to 0. So yes, it doesn't. It's not true for all functions. It's generally not true for all functions. It's not generally true for all functions. Do you have anything else? I hope you didn't miss this. Yeah. Anything else to say is okay. Let's search up. I'm gonna search up QuickTime. It's convex and concave. It should be one. I think it should be a one. Let me just search it on Google. Fine. Concave versus convex func. Okay, so convex it looks like a V. Concave looks like a entrance to a cave. If that's the way you remember it. Last one. It doesn't have to be the last one. You can make it more if you want. Okay. Figure 5 shows the sketch of the curve C with equation y equals f of x. The curve C crosses x-axis at the origin, so x is a factor, and at the points A and B are shown in the figure. Given that f of x is to k minus 4x minus 3x squared, show that C has a point of inflection at x is equal to minus 2 over 3. Okay, 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 okay. Okay, so I'm not I don't see straight away what to do. One sec. Let me think about this. Well, first of all, I know f of x is equal to x times some function q of x. So because it has no. Now what I want to do is find show that. Okay, first let me do this. Okay, yeah, never mind. The method came into my head as I was thinking. Anyway, show that c has a point of inflection. I think that's when f of prime prime x is equal to 0. So that's when that's saying minus 4 minus 6x is equal to 0. So x is equal to 4 over minus 4 over 6. So that's minus 2 over 3, and that's as required. Um, okay, part B. So as I was saying, um, yeah, as I was saying, this has no okay. So this is a key part of this. This curve has no constant. We're given that f of x, f prime of x is can be written as this form: k minus 4x minus 3x squared. Now f of x is going to be the integral of this, correct? Is going to be equal to kx minus 2x squared minus x cubed plus c. But key thing is here, we know that there is no c. We can see there's no c. Haha, pun. There's no c. So that gives us f of x is equal to factoring out x, which I initially said that it can be written as this form, x times k minus 2x minus x squared. Okay, nice. Another question. Okay, so now I know that a and b exist. Lie where the solutions of this quadratic are. So now I'm solving. I'm solving for x squared plus 2x minus k is equal to 0. Don't have a calculator on me, so x plus 1 squared minus 1. Uh, x plus 1 squared is equal to k plus 1. So x is equal to minus 1 plus minus square root of k plus 1. Is that correct? Minus 1 minus k. Yeah, that's true. Okay, cool. So A and B lie on these points. Is k positive? Okay, we don't know. But we do know that the distance between A and B is 4 root 2. So the distance is literally going to be the difference between these things. So minus 1 plus square root of k plus 1. Let's say that's B. That's the more positive one. Assuming it's a more positive one. Subtract minus 1 minus root k plus 1. Minus 1 minus minus 1 cancels out. And then you get, oh, that's still it's a minus. So then root k plus 1 plus root k plus 1 is equal to 4 root 2. So 2 root k plus 1 is equal to 4 root 2. 2 root 2, square root both sides, k plus 1 is equal to 4 times 2, which is 8. So k is equal to 7. And 7 marks. Confirmed? Let's check them on 2 times. Yeah, that's fine. Okay. Hope that answers your question, brother. Next question. Damn it, Microsoft. 2, 2, 3. Yeah, sure. No problem, bro. Um, Okay. 4,500 tons of a mineral of a mine in 1 year during 2018. The mass of the mineral which the company expects to extract in each subsequent year is modeled to decrease by 2%. Thank you. Find the mass of the mineral which the company expects to extract from 2018 to 2014, inclusive. Giving an okay, so straight away I'm just gonna straight away here say 2040 minus 2017 is a number of years. So that is it's 23. Yeah, that's right, 23. That's the number of total number of years. That's what I'm saying. That's what I'm gonna straight away. Now we have that the value n is equal to 4,500 times 0.98 to the power of n minus 1 for the amount of mineral mined in a year n in any year n is gonna be given by this formula. Um, Find the total mass of the mineral which the company expects to extract from 2018 to 2040. Okay, so that's the sum. So 4,500 plus 0.98 times 4,500, etc. up till until 0.98 to the power of 22 4,500. So the formula is a1 minus r to the n over 1 minus r. Okay, hang on a second. But is n the number of terms or is n? Let me think 1 second. I think it's 23. Um, I think it's 23. Yeah. So you do 4,500 1 minus 0.98 0.98 to the power 23 over 0.02. I'm not too sure now. Thinking about it, I do know the total number of years is 23. If n represents the total number of terms, then this is correct. Oh, I'm not sure, man. I can do. Okay, I'll derive it later to be sure. Okay, cool. Anyways, okay, this calculation will give you part A. Okay, now part B. Find the mass of the mineral which the company expects to extract during 2040. It's gonna give is given by this expression un is equal to 4,500.98 to the power of n minus 1. So that would be 4,500 times 0.98 to the power of 22, because it's the 23rd year from 2018. Yeah, because the 2018th year you don't have a power. It's just the first term, but the power of 0.98 is 0, not 1. The cost of extracting the mineral each year are assumed to be 800 per ton for the first 1500 tons and 600 per ton for any amount in excess of 1500 tons. Okay, that's fine. Okay, so I approach this question this way. I think the point they got you to do part B was to show that even during 2040, the amount they mined was above 1500. I think this answer is, I don't know, 1700, 1800, something like that. So what that means is that every single year they mined at least 1500 tons. So they did get charged 800 per ton for the first 1500 for every single year. So that means from the total, not from the total, but that means for the total 23 years, for 23 years, we have 1500 tons, each being charged at 800. So that's an initial cost already. So cost one, you could say, is equal to this. Um, Now, the tons this represent, tons of cost one is just equal to 23 times 1500. And then the remaining tons is equal to the total which you calculate in part A, minus this tons of C1, tons of C1. And then what you do is each of those tons, or all of those tons, are the ones that were in excess of 1500, so they were charged at 600. So let's call this C2. I said T2. So C2, the second charge is equal to 600 per ton. So the total charge total is equal to C1 plus C2. That's it. Um, it's in it's in million, so times 10 to the minus 6. Divide everything by a million. Your total cost will be in not in millions, it will be in pounds because you worked in pounds. Um, so yeah, divide by a million. Any other question? Thank you. Okay, so two of you have been watching since the beginning. Uh, I think at least. Maybe someone else. Guess. Well, if this has been beneficial, that's good. How long do I plan to carry this on? I'm too sure.
Hey, this is Prash Talwalkar reminding you to mind your decisions. Here's a problem I received by email about
This is the reason why I was probably good at GCSEs. Just watching videos like this, man.
2 years ago. If A, B, C, and D are positive integers with a sum of 63, what is the maximum value of AB plus BC plus CD? I did some research, and the problem traces back to the Australian Intermediate Olympiad in 2013, 10, which I believe is the ages of 11 through 15. Calculators are allowed. And remember, students
Yes, Assalamualaikum. Yeah. Yeah, that's what I did. So what I done is I done the general formula for a specific term, which is un is equal to first term times the ratio to the power of n minus 1. Oh yeah, I see what you're saying. It is during 2040 only, but 2040 happens 22 years after 23 years after 2018. Like the compound interest applies. Yeah. It keeps on getting reduced from because it's only 4500 at 2018. Calm. So yeah, no, 2018 to 2040, a total 23 years, but not including 2018 is 22 years. So basically, the way this is what I done. You know, my first term is 4500. It does not have the ratio being multiplied to it. So my second term is when the first power of my ratio comes. Now, but n is not 22. N is 23 though. That's the thing. N is 23. It's just the power is 22. For 2040, yeah. So what I'm saying is, my first term is the expression for is when n equals 1, the term is a. So when n equals 1, it's a. When n equals 2, it's a to the r, where it's first power. Yeah, exactly. No, yeah, that's in the year 2019. So that tells me that for any year n, the power of the ratio is n minus 1. That just tells you the amount of tons extracted during that year n, just during that year. Yeah, because the ratio is less than 1. Yeah, yeah, sure. Yeah, you could say that. So if it does ask, what it suggests why the amount of minerals is decreasing, the cave is running out, beginning to run out of minerals. Cool. Have you been watching it this entire time? Is it beneficial? Okay, cool. That's good then. You're safe, man. You've been one of the two people that you've been one of the two people that watched it since the beginning. Oh, okay. Right now you're the only one. Oh, okay, okay, okay. Calm. No, no. You're watching the YouTube video. Yeah, man. I can't. Like you took a break with me. You get me? I can't. Sure, man. I'm tempted to play Osu. Uh, probably not. I'm gonna go sleep soon, I guess. Ah, I've had worse. Cool. Shout shout. Assalamu alaikum. Man, imagine the entire class was here. That would be pretty nutty. um,
Students haven't taken calculus yet, so limit yourself to solving this problem using geometry and algebra. I'll admit, it's a very hard problem. I wasn't able to solve it. If you'd like to give it a try, pause the video right now, and when you're ready, keep watching the video for a solution.
what the hell? Okay, so first thing I see that D only comes once. A comes once, B comes twice, and C comes twice. So they should be the biggest. Should they be the biggest? Uh, yeah, sure. I remember doing this question, so I think I remember this question at least. Thank you for the question. That's a problem, isn't it? Um, so the one sec. Okay, that's good. How do you know when to do it, math? Okay, I'll answer that. I'll get back to that after I finish this quick time. So, show that a Cartesian equation of C can be written in the form that. Okay, so first of all, x. Oh man. There you go. Okay, first of all, First, I have an x plus y squared. X plus y squared. So I know sine squared plus cos squared is 1. So maybe I can try get that somehow. First of all, I'm gonna rewrite x as both of those. What do you call it? Expand the double bracket. You know what I mean? 4 cos t cos pi over 6 minus. This is a bit too zoomed out. Yeah, that was a bit too zoomed out. Minus sine t sine pi over 6. Is that right? Yep. Yep. Cos of pi over 6. So pi over 6 is 30. Is it? 6 of 18. 30. Yeah, it is 30. So that is 4 cos t. And cos of 30 is root 3 over 2 minus sine 4 sine t. Sine of 30 is a half. So 2. So that's equal to 2 cos 2 root 3 minus 2 sine t x. I have y is equal to 2 sine t. Okay. Okay. One second, I'm just thinking if I okay, cool. So 2 sine t. This is y. This is equal to y. So x plus y is equal to 2 root 3 cos of t. And do we want x plus y? We do want x plus y. We also want x plus y squared. So for the hell of it, let's square it. X plus y squared is equal to 2 root 3 squared. That's going to be 4 times 3, 12 cos squared t. Now cos squared t is the same as, yes, you're right, 1 minus sine squared t. Um, now 12 sine squared t is the same as 12 minus root 12 sine t. Um, are these integers? Are these integers? Oh crap, they are. Yeah, that's not good. Oh, minus sine squared. Cos squared plus 1 minus, yeah, that's right. X squared plus y squared is equal to 12 minus 12 sine squared t. Root 12 sine t squared which is equal to 12 minus root 12 over 2 2 sine t squared. So 2 sine t, that's a y. Now what's root 12 over 2? That better be nice. It's not, is it? Oh no, it's gonna get squared. Oh, that's fine. Oh yeah, that's fine. Root 12 over 2 is root 12 over 2 is root 12 over 4. Root of 12 over 4. That's root 3y squared, which is 12 minus 3y squared. So x plus y squared plus 3y squared is equal to 12. A and B are your integers. A is 3, B is 12. 5 marks. Not too bad, not too bad. Oh, another way you could have done it is um, I don't know. This is a pretty straightforward way. The key thing here is spotting this, I guess. Is equal to y. and then taking it to this side. It's kind of seeing what I want and seeing what I want to get to and getting to that. Okay, Daniel. To answer your question, when you have a geometric series that begins with a, that means the first term n equals 1 is a, second term is ar, third term is ar squared. So n equals 2, but the power is 1. The power here is 2. Yeah. So ar for the nth term is ar to the n minus 1. Now the general formula I'm gonna derive it just for the sake of I needed to derive it anyways. Uh, so this is the sum. Yeah. So let's say S is equal to this. Now SR is equal to A R plus R squared plus R to the N. So S plus SR is equal to this plus this. Oh, is it minus? It should be minus, yeah. This minus SR, you get, so A is survives, but AR cancels, so this cancels with this. R squared cancels with that. N minus 1 cancels with n minus 1. And what survives is A plus AR to the N, or A 1 R to the N. Oh, okay, so that means in my formula I said 22, it should have been 23. It should have been 23. Okay, that's gone. It should have been 23. Oh crap, I need to tell Zayn then. Message him. Yeah. I don't know. Um, don't worry, it's fine. Where n is terms. So that means that for the sum, n is defined as a number of terms always. So you just have to remember that for the nth term, the value of the nth term, it's ar to the n minus 1 because the first term is a and not ar. It depends on how you define your sequence. For example, if you say that a sequence 2, 4, 8, 16 is okay, yeah, sure, Daniel. So if you say 2, 4, 8, 16, if you say a is equal to 2, therefore r is equal to 2, so you have, yeah, true, number of years. So then you have ar, and then the general formula is hold. But if you said a is equal to 1 and r equals 2, this is like weird. You wouldn't do this, and you say the first term is ar, then your general nth term would be ar to the n, and your sum would be a1 minus r to the n plus 1. So your formulas just changed with respect to that. But in terms of when is it n minus 1, n plus 1, the short answer is for a specific term it's n minus 1, for the sum it's n. If you're listening, yeah, that's it. Yeah, exactly that. Yeah. Sorry, I didn't read this, but you can rearrange after getting one minus n squared. Yeah.
Pause the video right now. It's a Maction abstract thing. Why would anyone? Let's use an area model and a width C. To get CD, we add a width of D. Let's complete this rectangle. This final rectangle here will have an area plus B of the entire rectangle, which has sides A plus C. Thus, well, to maximize the blue areas, we can equivalently maximize the area of this rectangle minus AD. Length and width, the sum of the blue areas is maximum if A is as small as possible. All of the variables have to be positive integers, so the smallest positive integer will be A is equal to 1. Let's visualize visualization of that. We therefore have translated the problem into something a little more manageable. We deduced that A and D need 61 back into our original expression, and we end up with an ideal geometry. X plus gamma is equal to 0 happens equal to vice versa. That C has C is equal to 30 and C like this 191, and that turns out to be something we can understand through geometry. Incredible. And integer vector that is equal to deducify this. To get BC, we add a
10-year-old kids are doing that.
geometry. X plus gamma is equal to 0 happens equal to vice versa. That C has C is equal to 30 and C like this 191, and that turns out to be something we can understand through geometry. Incredible.
Come. Which USB? पता नहीं गिर गया पता नहीं यार ओ ये रहा Yeah, yeah. Assalamualaikum. It's just my part A is different, and because of my part A, my part C is different. Part B is the same. I should have done 20. But I done n minus one in my formula, but obviously I'll look in my formula book in the exam. It's up. It's one. It's a 1 minus r to the n. I know. I know. It comes from the formula. Like I derived it. You'll find it in the live stream. I derived it. Um. So yeah, it's up to n. I didn't really explain it. I didn't really explain the derivation, but basically what you have is up to the nth term. Yep. There's no reasoning to it. Like it's you can't really understand it as well. To be honest, just honestly, yeah, yeah. Yeah, inclusive. 23 years. Yes, yes, yes. Yep. That's not the reason why it's n, but yeah, it's the reason why n is 23 because you have 23 years. It means that both the upper and lower numbers they mentioned are included. So when they say 2018 and 2040 inclusive, it means you include 2018 and you include 2040. I mean, they say that to be very specific, but if they didn't write that and they mentioned information in the stem saying, oh, in 2018 they removed 4,500 tons, what's the total tons they removed 2018 to 2040? You'd assume it's inclusive, but they don't want people to assume and make mistakes, so that's why they're specific, and they should be specific because math is a specific subject. We do assume a lot of things, but we don't assume things that shouldn't be assumed, like genders. Yeah. Could get banned. You know what I mean? I'm joking. My three viewers, which three of my viewers are gonna report me? Waste man. Calm. Sorry, bro. Okay. Let's just turn this back to normal. At least that much, I guess. can't. Yeah, this is Newton. This is exactly that Newton-Raphson question that I wanted to. I was talking about. Yeah, exactly this. So, do you want me to do it, or do you have your answer to it? Like, um, show the alpha lies between thing. You plug in alpha minus 1.5 and minus 1. So you do f of minus 1.5. You do f of minus 1. You say there is a sign change, and f of x is continuous in the interval minus 1.5 to minus 1. So if because it's continuous and there's a sign change, therefore root iterative formula where so this is a Newton-Raphson, but yeah. Um, with x minus 1, so x2 is equal to square root minus half e to the x1 minus 1 over x1. So you go to your calculator, you first type in 1, so minus 1, and you say equals, and that's answer. Then you go down to your then you delete that, delete as in you type this in, then you say half e to the answer minus 1 over answer, and you click equals. Once you click equals once, you get x2. If you click equals twice, so equals times 1 equals times 2, you get x3, and equals times 3, you get x4. You only need x3, so that's fine. You only need up to x3. Find the value of alpha. Well, now, to find the value of alpha, what you do, you keep on pressing equals until the first, so let's say it's like 5.963455, and you press equals and it's 5.962455, and then it's 5.962463. So what you see is that the first two decimal places are not changed anymore. The third decimal place is now constant. When the third decimal place is constant, it means that the second decimal place is not affected anymore. So therefore, you know it's 5.96. You basically keep on pressing equals until this number stays the same again and again. Part B. A student takes 3 as the first approximation. Given f of 3, you apply Newton-Raphson once to obtain a second approximation. Okay, you only have to do it once, so part B, you do once. Newton-Raphson is x n plus 1 is equal to x minus f of x n f prime x n. F prime of x is now gonna be given, so f prime of x is equal to minus 2 over x squared minus e to the x plus 4x. That is your f dash x. So x n plus 1 is equal to, what's the value they gave you? Oh, never mind. They even give you f of 3 and f prime of 3. That's so then basically all you're doing is, sorry, you didn't need any of this. You just say 3 minus 1.4189 over minus 8.3078. Minus cancel out. So this is equal to your approximation, and that's it. That's it. A different student starts at 1.5. Explain whether or not this starting value gives a good approximation for beta. Well, here's the thing. 1.5, if you draw the tangent, I'll draw it here. 1.5 tangent goes like this. It is not a good approximation for beta. It goes to alpha. If anything, it's a very good approximation for alpha. That's it. That's your reasoning. This gives you all the marks. Tick, tick, and tick. Oh, that was nice. Ah, flip. बीच में मत रखो साइड में रखो Oh. miss for assassination classroom. Oi, 4,000, finally, what the hell? Time. It's a... Yo. One come. Gone. Oh. And this will probably be my last question then. Oh, the tournament. Safe, man. I've been playing it for quite some time, so I'd expect to be pretty good at it. I come then, Base. I want the only way, man. Come, what do you want? Bring it. Bring it. Nah, Base, I want the only. No, gone. Okay, cool. I'll do this question on live stream, yeah? Yeah, calm. Come live stream then, yeah? Sorry. Okay, we've got another question. The last question for today, lads. Um, and then I'm gonna call it a day with some Osu. Where's paint? Sixty, 50, 30. Ah, yeah, that's fine. Okay, so when you sub in 3, you get a half, and cause it's a half at um root 3 over 2, pi over flipping, what do you call it? Yeah, it's at 60 degrees, so that's pi over 3. Yeah, that works. dx by d theta, which is times 6 um well, hang on a second. Dx, yeah, that's right, dx by d theta times 6 minus sine t dt. That's a minus 30 integral of sine 2t sine t. Now that's a bit long for 7 marks. I mean, it is. I mean, not for 7 marks, but it's 7 marks. That's why it's long. But basically, yeah, okay, well, let's carry on. Minus 30 integral of 2 sine squared t cos t um and then you can say that's 1 minus cos squared. We get cos cubed. You don't want cos cubed. Yeah. What if you just done? Yeah, you can just do reverse chain. Reverse chain. So that's minus 60 integral sine squared t cos t. Consider sine cubed t. Sine cubed t goes to 3 sine squared t cos t. So you just do is equal to minus 60 a third. Yeah, sorry. Yep. Yep. The reason why I rearrange for t is because this is parametric. So when you integrate parametrically, you have to get it in terms of the parameter. So when you normally you just do integral y dx with respect to x. So your limits are with respect to x. But because this is parametric, you do y dx by dt times with respect to dt. No. I'm okay. Okay, I see what you're trying. So you're thinking of making is the Cartesian equation, which is when you put x into y. You don't have to do this for this question. When you're integrating parametrically, you can just do it parametrically, which is the way I've shown here. Y dx is the same as y dx by dt. The dt's cancel out in a way, but it lets you do it with respect to t. No, so I want because this is y in it. This is y and this is x. So this is represented by the integral of y dx. Yeah, I know it doesn't have an x. This doesn't have an x in it, but this does. And the area is represented with x and not t. So that's the point. The point is that I mean that's this problem. The problem is that the area is with respect to x, but my equation with respect to t. How do I get about this? Making a Cartesian equation could be long, and in this case it does seem pretty long. So you get about it by doing this technique, which is y dx is the same as y dx by dt. Yep. Yeah, because we want to do it with respect to t. That's the point. We don't have things like we know x is 3 and 0, but we don't have a x in the y equation. So we change it into we bring it into the t world. And when you're in the t world, you have to have t equals. Here it's x equals x. You can't integrate that because to integrate that you need y in terms of x. No, you need the y's to be in terms of x. As in when I say y, I just mean this function. This function. Exactly. Because it's with respect to x, it needs to be in terms of x. But because it's not, it's in fact in terms of t. We have this middle term, dx by dt, to help you out. Oh, I see. No, okay. So you're saying what's the actual integral of y? The integral of y dx is. Can you see y? Like, are you saying y is a look? When I say y here, I mean y is a function. So this is y of t dt dx. This is a function of t. But if you're saying y is a variable, like you know how you have egg y squared, like y, this y. Yeah, no, I didn't mean it as that. I meant y as this is look. This y is equal to a function of t, and the function is 5 sine 2t. Do you see that? Because it's a function of t, the integral of that it will have to be dx by dt times dt. But if you just want to integrate y with respect to x, the integral of y is just yx. Because y is a constant. If you're doing something with respect to x, you can treat all other variables as constants. That's calculus. Yeah, parametric integration. Cool. And the rest of it is just carrying on through the integration. Save, bro. Oh, that's done then. Safe. He's gone. Oh no, I'm not speaking. Um, I wasn't saying nothing. Sorry. So basically, what I'm trying to do is I'm trying to find the point where they meet. The point where they meet is when their y values are the same. Kx squared is equal to square root of kx. I'm squaring both sides. K squared x to the 4 is equal to kx. Um, taking both to one side and factoring out an x. We already know one of the solutions is x equals 0, so we can ignore this essentially. Basically, the remaining polynomial is k squared x cubed minus k is equal to 0. Rearranging to make x a subject give you k to the minus a third. K to the minus third. Um, Next thing we notice that root kx is a larger area. So what we're doing is we're going to first work out root kx's area, which looks like this, and we're going to subtract from it kx squared's area, which looks like that. So this is area 1, this is area 2, basically. So area 1 is going to be the integral of root kx, root kx from um, k to the minus third 0 dx, and we're subtracting basically this with the integral from up to k to the minus third from 0 of kx squared. This is something we can do very nicely, so I'll leave that. This is the thing that we need to integrate. So what do we have? We have a root k function, a root k constant, and you have x to the half inside. Okay, not that bad, is it? So raise the power by 1, divide by new power, you get so raise the power by 1 gives you 3 over 2, so that's 2 over 3 root k, um, and that's x to the 3 over 2 minus, we're going to do the integral of this already. Can I do the integral of that? No, I can't. 3 over 2, x to the 3 over 2. Okay, yeah. And this goes from k to the minus a third 0 minus, now factor out the k and factor out the third, k over 3 um, x to the 3 with limits k to the minus third 0. This gives us 2 over 3 root k. Now x to the 3 over 2, so that's k to the minus third times 3 over 2 gives you minus a half. So k to the minus a half minus 0 minus k over 3 minus a third cubed is just minus 1. So k to the minus 1 minus 0. Very nice. We wanted that. So this gives us 2 over 3 root k over root k minus k over 3 times 1 over k. So that's just 2 over 3 minus 1 over 3. I hope that's the right answer. Oh yeah. 2 over 3 minus 1 over 3, that's a third. And it's independent of k. They all just have to cancel out. So yeah. I wouldn't read. In my exam I wouldn't do it this scruffy. I wouldn't do both integrals at once. I'll do one integral at a time. I'll lay out a bit better than this. But yeah, that's how you do it. Alright then, I wanna end the stream. Assalamu alaikum brothers.